Okay, so in this section of calculus, I'm going to go over continuity because I did the part before this and it wasn't good because I talked a lot about stuff that we use in continuity. So I'm just going to talk about continuity first because it's important to do what we do. Okay? So continuity, what is the definition? You need three things for a function to be continuous. One, f of c must be defined. And we'll look at graphs here in a bit. 2, limit as x approaches c of f of x, it exists. Okay? So it does have a limit. And then 3, the limit as x approaches c of f of x equals f of c. Oops, f of c. C. Okay? And so this, and that's the definition of continuity. So let's look at a couple examples here that are important to know. Oops. Kind of drew that wrong, but we'll be fine. Boop, y, x. Okay, so we have a, we have b. Okay, and we have a function, and it comes through, but then it has a hole in it, and then it goes through. This is discontinuity. Discontinuous. Because it's not defined. F of c, not defined. Okay, the one-sided limits would agree here because it's approaching this value right here, but it's not defined there. This is a removable discontinuity because if we define the f of x at that point, or f of c equals da da da, we can define it and fix the hole and make it better. Okay, another example, this one is kind of the most important, is this one. So it comes up, boop, dot, it's there, but then the graph continues like that. This is also discontinuous, and this is non-removable discontinuity because one-sided limits disagree. So follow the logic here. The one-sided limits disagree, so there is no limit, and since it has no limit, it's discontinuous, and because it's and we can't redefine that. So this is a type of discontinuity we can't fix. And then a last case of continuity would be this case right here. So boop, we have a hole, but it's defined somewhere else, and it continues on. So it's discontinuous because it's not defined there. Well, it's discontinuous because it is defined here. See, it's defined down there. So it is defined. The limits agree because the limits are coming in on each side. But this last one, 0.3, limit as x approaches c doesn't equal f of x, does not equal f of c. So if this were c, this would be the f of c. The f of c equals that, not where it should. This is one we can fix, just redefine. So this is removable. And this leads us to important functions to remember. And this is important. Polynomial, rational, radical, composition, trig, logarithmic, exponential, and composition. 1, 2, 3, 4, 5, 6, 7. There's 7 of them. These are important because they're all continuous when defined. So if they are defined, they are continuous. That's what's important about these 7. And a little side note, like a little asterisk, a little note I have at the bottom of my notes in front of me here, is that if a limit exists, then the discontinuity is removable. So if we look back at our examples, this one has a limit. See, the sides come in and agree. Sides come in and agree. Removable, removable, non-removable. Hope that was helpful.